Alright, so we're going to do a quick review of our exponent rules, and the first one we're going to look at is multiplying two things with the same base. And you can see here that if I multiply a to the m times a to the n, where of course a is the base, they have the same base, they're both base a, what we end up doing is adding the exponents. And if we look at it with some numbers, it's clear to see why that's the case. So I have a to the fifth times a to the fourth, and a to the fifth we know is a times itself 5 times, and a to the fourth is a times itself 4 times. And so then we see that we have 9 a's being multiplied together, which is of course a to the ninth, and it's clear to see that that's just adding the exponents. If we're raising a power to a power, we can see that what we're actually going to do here is multiply the exponents together. And again, if we put in some numbers, it's easier to see why this is the case. So if I take a to the third, we can see that that would be 3a's. And if I square a to the third, it says multiply 3a's by itself twice, and I would get a times a times a times a times a, which would be a to the sixth, or in other words, 3 times 2, which would be multiplying the two exponents together. And hopefully, from this same idea, you would get the idea that when we divide two things with the same base, what we're going to end up doing is actually subtracting the exponents. So again, we can kind of see it if we stick in some numbers. So let's go back to our a to the fifth and a to the fourth, and we can see that that is 5 a's with 4 a's underneath. And if you think about canceling them out, then we would cancel these guys out or divide, or however you like to think about it, and it would be an a to the first, which would be a to the fifth minus the 5 minus the 4 would give you the 1. You can also do this if the bigger number is on the bottom. It still works. If I say a to the fourth over a to the fifth, this would actually be 4 a's on top and 5 a's on the bottom. And from here, when we start to divide or cancel, or whatever word you like to use, we can see that what we end up here with is a 1 over a to the first, or 1 over a. And so we subtracted them. It would have been a to the fourth minus 5, would have been a to the negative 1, which of course brings us to our other exponent rule. So if you don't realize why a to the negative 1 and 1 over a are the same, well, of course, that's one of our exponent rules. So let's take a look at that one. We're going to start by looking at maybe a to the third. So let's take a look at these numbers. I have a to the third and a to the second and a to the first. And what I'm going to do is I'm going to start to go down, and we're going to look at this. So we see that this one is a to the third is a times a times a to the second is a times a. And as we look at this, how do we get from a to the third to a to the second? We actually have to divide by a. And if it's hard to see with a's, think about it with 2's. Sometimes if we have a hard time understanding the numbers, the values as variables, it's easier to understand them as numbers. So if I look here, we know that a to the third is, 2 to the third is 2 times 2 times 2, which would be 8, and then this one would be 4, and this one would be 2. And you can see to get from here to here, what did I divide by? I divided by 2. Just like over here, I divided by our base to get down to there. And as we continue to go down, we're just going to keep dividing by 2. And if we follow this, then we can see if I'm using the same pattern, then a to the 0 is going to be 1, and a to the negative 1 is actually going to be 1 divided by 2, which is a half. And we can keep following this same rule. If I divide by 2 again, which is the same as multiplying by 1/2, those two things are the same idea. Of course, when I divide 1/2 by 2 again, I get a 1/4. Or in other words, this one would be 1 over 2 squared. So the negative 2 means that I'm going to have the 2 in the denominator, and I'm going to square it. And the same thing would be true over here. If I keep dividing by the a to the second, I keep dividing by the a, this one is going to give me a 1 because this one will be just a. When I divide by a, I get a 1. When I divide 1 by an a, I'll get a 1 over a. And a to the negative 2, I divide by another a, so it would be 1 over a squared. And so the rule that we say here is that a to the negative 1 is going to be 1 over a, or in other words, you're raising the reciprocal to whatever that exponent is. The other thing that we can think about is if I had 1 over a to the negative 1, that would be like saying a to the first. So it works both ways. You're raising the reciprocal to that power. And as we just saw, if I raise anything to the 0 power, that is a 1. And the last thing we'll just mention, even though you probably don't need it in the section that you're working on right now, just in case you haven't seen it first, a to the 1/2 is actually the square root of a. And this works for all different ones. The number on the bottom becomes the index of the radical, and you can write them as radicals instead of exponents with fractions, or vice versa. You can put them back the other way. And if you happen to have one with a number on top of the fraction other than 1, then that means that you're raising the radicand, or the number inside the radical, to that power, and you are taking it, the index is still the denominator. Or the same thing would be this one. You could write it with the 3 on the outside. Those are actually the same values. It doesn't matter which way you look at it. So that's a brief review of your exponent rules, and hopefully that will help you with your upcoming assignments.